All right, let's talk about our final property we'll talk about in this section, solubility. And so when it comes to solubility, the saying is like dissolves like. And so what that means is that polar compounds dissolve polar compounds. So polar dissolves polar, and then nonpolar dissolves nonpolar. Right. And the whole reason this is done is to maximize attractive interactions. Right. The polar molecules want to stick to one another because they can have these dipole-dipole interactions, right? And so one question we could ask is, will it mix? Right? Could we put this molecule right here in water? Right. And so what you want to look at is what this molecule is, right? This is ethanol, 2 carbons, oxygen, and then the hydrogen, right? And so you can tell this molecule is polar and it has H bonding as well. Water, on the other hand, is also polar and has H bonding as well. So they're very similar to one another. So they're the kind of the same, or they're like each other. And so, yes, they will dissolve or mix. What about the same molecule, ethanol, right? We can still say it's polar and has hydrogen bonding versus something like C6H6, right? Well, C6H6, we learned that carbon-hydrogen and carbon-carbon bonds are both nonpolar. So this molecule overall is nonpolar. And so they're unlike, or they're opposites, whatever you want to say. And so, no, they won't mix. And then finally, what if we have a situation like this, right? 5 carbon long chain and something like this, right? All carbons and hydrogens. Well, we know when we have carbon and hydrogens, they're both nonpolar. So this is nonpolar and this is nonpolar. So will they mix? Well, they are like each other. So yes, they will mix. Right, and this is the kind of thing that you want to be able to do. Look at a molecule and figure out its properties. So to kind of summarize what kind of organic chemists do, and what you will be able to do as an organic chemist is you can look at lines / letters, right? Something like this, right? It's just 2 lines, an O and H. And just by looking at this, you can see the structure, right? Both physical and electronic, right? So polarity, that kind of thing, right? You look at this molecule and you say, oh, look, there's a carbon right there. It's in a tetrahedral shape. It's connected to another carbon that's also in a tetrahedral shape. It's then connected to an oxygen that is in a bent shape. And there is a dipole moment right there, making the polar molecule polar, right? That's what the electronic mean by that. And then you can see this structure, and then you can use that to predict the properties. And so you can say that this will then have a relatively high boiling point because it's polar and has hydrogen bonding, and you know it's soluble in polar solvents, right? And so we're just going to expand on this more and more and more, and you'll be able to look at more structures and get even more and more detail. And the real trickiness is really going to come through the electronic structure that we'll start touching on when we get to acids and bases. These lines can be a lot more complicated than they look. But for right now, you really need to master this physical, right? You really need to master your knowledge of these skeletal structures. It's super, super important. I cannot overemphasize how important it's going to be.